Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 92, Count Palindromic Subsequences. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I actually kind of dig this problem, though, it's very specific, but sometimes that's all problems are, right? Because they're running out of problems that are more generic, or more general rather. But yeah, so the first thing to notice is that each answer has to have length 5. I don't know why they don't put it in the subtitles or in the title, right? Because I actually definitely did not read the length 5 thing until I don't know how. I mean, maybe just because the problem is very short, so I eventually saw it, because that took me a few moments of and I know that is an example, but but. So that's basically the one of the trick, and given also the other thing is that n is 10 to the 4th, so you can't do anything n square again, because that would also make it a basic dynamic programming. But yeah, so then the idea here is just, okay, it's length 5. How do I exploit it? I honestly, it took me a while. I think the first thing I wanted to exploit was, okay, so. Well, the first thing I noticed during the contest was that, okay, so it's length 5. What does that mean? That means that there's always one digit in the middle, right? Okay, so if there's one digit in the middle, what does that mean, right? The one digit in the middle means that, or at least for me, it just becomes like a dividing point, meaning that if I want to do a palindromic subsequence of length 3, then what does that mean? That means that, and the middle number doesn't matter, but for me, it was just, okay, I know an answer to solve this if I was doing a palindromic subsequence of size 3. For size 3, for example, we just count, okay, if there are x zeros on the left, y zeros on the right, then, you just pick any of them in some combination. Of course, it's going to be x times y number of combinations. Hopefully, I don't have to explain it, right? So yeah, so that's basically the idea, right? And then I was like, okay, then I could loop it for a palindromic of length 3. That's 10. That's 10 things, right? Like 0 to 9. The alphabet is 0 to 9. So, yeah. So that's basically the idea there. Is that for a palindromic subsequence of length 3, we can brute force every middle point, just going from left to right, and then count the number of zeros, count the number of ones, and then do the math that way, right? It took me a little bit while, to be honest, to figure out how to extend that to 5, because I was still stuck on, like, okay, well, we still need to know like one more layer, right? Like, we still need to know, like, in another naive way of thinking about it is that, okay, now that we have the 3 setup, maybe, or we want to exploit the 3 setup in a different way, then how do I go from 3? Like, you still need for me, the problem that I was seeing is, struggling with, was that, okay, there's still a left and a right, but as soon as you have a left and a right, and you have to, do a loop, that's going to be n squared, right? So I couldn't figure that out. And then I was kind of coming around with the idea of that, okay, well, 10 times n is slow, but 100 times n is going to be okay. So then that's basically what I did. But it took me a little bit more time to kind of put it together, and I took kind of a long time on this one, only, and you could see in the video, because I made a really bad typo, and kind of debugged it for like 4 minutes, and that kind of, was not good for my ranking, but I still got it. The idea there then is to so the same idea for palindromic subsequence of length 3 for k is equal to 3, let's just say call it k, to extend to 5, is that the idea behind 3 is just, even though we have one digit and it's easier to visualize, is just the number of possible prefix and then the number of possible suffix, and they have to match, right? So that's basically the idea of k is equal to 3. For k is equal to 5, you can do it again, right? And except for now, instead of a prefix of length 1, it's going to be a prefix of length 2, and also same for suffix, of course. And now, instead of a number of going from 0 to 9 inclusive, it's going to be a 2-digit numbers from 00 to 99 inclusive. So that's basically the idea. And once you count them up, and that's the basic idea, right? And once you have that idea, there are a lot of ways you can code it up. I'm going to show you mine, of course, but yeah, that's pretty much the idea. And yeah, cool. Let's kind of take a look. So I wrote this function to, I send a mod song. So I wrote this function to calculate the per index prefix from 0 to 100. Yeah, and the idea is just, and this is just dynamic programming. I say just, dynamic programming, you could, or the way that I thought about is with dynamic programming, you can do it with other ways. Just the idea is just to make sure that you keep track of all the prefixes and all the suffixes, and yeah, so they all start at 0. This is just to copy the array over, and then after that, let's say we have a x. So if x is 5, then we obviously this one is the k is equal to 3, and this is k is equal to 5. So yeah, so we increment by 1, but then here we also brute force the 10 previous digits, right? Meaning that, okay, so if x is, let's say, and I call it j, but so you have x and a j, and so let's say x is equal to 5, then we go, okay, how many 05s are there? Well, the number of 05s there is the number of previous zeros there are before this index, and so forth, and you do it for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's basically it. So I wrote this function as a function so that I can also calculate the suffix in an ugly but still working kind of way. Yeah, and then as we said, when we have the answer for each index, we just look at the number of prefixes and the number of suffixes, and that's pretty much it. And then you multiply them together because that's the number of possibilities that you can choose from a universe of them, and then you mod them afterwards, and that's pretty much it. This is going to be 100 times n, so you could say O of n, but what I like to say is you have A as in alpha, as in the size of the alphabet, and the alphabet, of course, it's going to be the number of digits in this case, which is 10. But if you want to say more precisely, it's going to be O of alpha square n, and yeah, both in time and space, because you see this here. Yeah, that's pretty much all I have for this one. So yeah, let me write down the complexity. O of alpha square n for time and space, where a is the size of the alphabet, 10 for digits. Yeah, and turns out you could fit everything in one screen. Cool. That's pretty much all I have for this one. So let me know what you think. I think the concept, once you get, I really hope that once you get the concept, you just implement it, or give it an honest attempt to implement. But yeah, that's pretty much it. Cool. Let me know what you think, and you could watch me solve it live during the contest now. I actually kind of did this in a weird way. Okay. mod. Put in the right mod number as well. Okay. Okay. How am I doing so far? Wow, people are already close to done. Right? Hmm. 10 to the 4th is a big one. Subsequence, not subarray. Oh, why do they miss the link 5 portion? The 5 is pretty important. Okay, then let me rethink this. I mean, I think that's probably part of the answer, otherwise it's 2 to the 7, but still. So n square is too slow. Or is it? No, it is. Okay. merge them. Good. That, all these are n square and 10,000. Well, 5 means that there's one digit. And then, can I expand out? Expand out doesn't seem right either. I mean, or at least like it's still n square. Can we count the number of ways? So for each number that's the middle, maybe we can do something like still n squared, right? Isn't it? But we can maybe pre-calculate. Don't know how to do it without. Actually, is it another prefix thing? Then you can do 10 to the 5th times 10 times 10 or something. Yeah, a lot of people. Yep. Still faster than me though. Okay, let's say we have the middle one, then it's easy to count the number of things on the left and right for 3 digits. But how do we bracket it? Without enumeration. It's good that I read this earlier though, because I was thinking of something even crazier. Yeah. I think this is some like, I don't know. 100. I see. I think I have an idea. Okay, that's crazy talk though, but okay, I think I have an idea. It's these people are so small and so fast. I am not so much, but okay. Focus, 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 focus. Okay, for okay, I think I got it. Okay. Shadowing is kind of scary. Okay. And then what do we want? Well, prefix of x increment. That makes sense, but maybe before that. Then oops. No. Okay, I think this is okay. And then we do count backs. Yeah. Is this right? I think this is roughly right, but it's a little bit off by. Oh, I'm being dumb. There's something off about this, but the idea is kind of right. Do we want this? But there's an I here somewhere, that's why. This is actually +1 for the prefix. And so this is Lucky I have prefix some practice from the previous problem. Okay. Okay. Just looking at it for a second. Then I have a comma. I did forget a comma. Thanks. Though this may be printing too much. Oh, didn't see it. J is gonna be. Oh, it's a hunt. No, it's. Okay. Oh, whoops. Maybe I -1 actually. J0 to 10. This is. Come on, man. Why am I getting? This is just normal one. IJ. I do it in normal order now. I'm so confused. So let's just take a look. And what is crashing on? 1 0. I is. Huh? I am debugging like a stupid thing. Come on, why are you out of bounds? Here's that line, right? Is this line, not the other ones? 20. Oh, now it's 20. I -1. I is. J is 0. That should be fine. Yeah, that should be fine. Why am I debugging this stupid thing? Come on, man. This looks okay. So why are you giving me an issue? Wah. Okay. So oh, IX is definitely. What is X? Is that right? Oh wow, I am a dummy. I am so good at programming. Okay. I am so good at programming. Yeah, come on, man. Okay, so this looks okay. I mean, it's printing crap, but does it have any ones? This should add something to it. Oh, because we added no. So there's stuff. What? Okay, so it is working. So maybe I just kind of misread that. Because this does not look like it has any numbers. Maybe that's just the way it is. Oh, there it is. There are ones. Okay. Okay. Well, that took a while. Whew. Okay. So then now. Okay. So then. What we want is prefix of I. Yeah, pre I minus 1 j plus times the suffix of I plus 1 j. Okay, let's get the base case right. N is not defined, of course. Why would N be? Oh, I think when the suffix is just I. 221 2. Okay. Am I confident? Let's give it some submit. Maybe some silly edge cases, but it's like linear-ish. Okay. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Hope you had a great problem, and let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.